everyone. My name's Savannah. I'm going to talk about Tungsten Fabric. First off, has anybody heard of Tungsten Fabric before? One person, two people, three people, 4, 5? Wow, okay, this is the most other people that I've met who also know of Tungsten Fabric. I'm going to talk about that and then also dive in a little bit to vRouter. So first about me, I study computer science at Oregon State University. I've been interning with the Network Connected Logic group for a while now, working on Tungsten Fabric and vRouters. I have a lot of experience working with DPDK, the Data Plane Development Kit, and in my spare time, I volunteer with local robotics and STEM outreach programs. This is a picture from when we took Girls Get It to Alaska, a small town, and it was the first time they programmed websites. So, kind of fun. So what does Tungsten Fabric try to accomplish? It has the broad goal of being an open source SDN with multi-orchestrator support. Some of you might know it as Open Contrail. It's the open source version of Juniper Network's proprietary Contrail software. It's developed as a response from telco NFV service chaining, and basically is trying to solve the question of how do you replace those big appliances and create software-driven services in networks. So a little bit more about the community and the code before we dive into the technical stuff. It's very large, as you can see. These are some of the companies that are involved in contributing and or using Tungsten Fabric. All the bug fixes and features are driven by the community. There's an active Slack channel. Yeah. It has been recently open source, so the community is still ramping up. So this is an example of a typical deployment with Tungsten Fabric. It previously was just a hypervisor-based SDN solution, and now it supports hypervisor, container host, and public cloud. It has overlay tunnels to ensure the separation of underlay and overlay states, so you can shift around service endpoints. It also is flow-based and aware SDN solution, so we can keep track of all the flows between the interfaces. And I'll show you more of that as we go on. These are some of the features in Tungsten Fabric. It does a lot more than just L2, L3 forwarding. Analytics is a huge part of Tungsten Fabric. As you can see, traffic flows and further information that can be used for troubleshooting, which is especially important when scaling over large networks. I don't want to just read them to you guys, so I'll give you a second. Okay, so what can you do with all these features? I'm glad you asked. Some of the common use cases is enable platform as a service and software as a service with high scalability and flexibility in OpenStack managed data centers. You also could do virtual networking with Kubernetes, container management system, including Red Hat OpenShift. You could allow new or existing virtualized environments running VMware vCenter to use Tungsten Fabric virtual networking between VMs. Or you could connect Tungsten Fabric virtual networks to physical networks using gateway routers and BGP peering directly through working with networking overlays directly through the data center underlay networks. So there's a lot of possibilities with Tungsten Fabric. So looking more at the architecture of TF, it's very much like any other traditional SDN-like architecture. You have your separate control and data planes. For connected VMs and containers, the vRouter is the piece of software that replaces your Linux bridge or your traditional IP stack. All forwarding and security application is controlled and enforced through the vRouter. And vRouter uses XMPP and XMLs to connect and transmit data to the controller. Yeah, cool. So the two biggest key software components to Tungsten Fabric mentioned previously is your controller and your vRouter. So your controller is your software services that maintain the model of the networks and the network policies, so you can have that running on several servers. And then vRouter is installed on each of your hosts that will run the workloads and performing packet forwarding, enforcing the network and security policies. Having a software-accelerated data plane allows us to control the flow of traffic, apply security policies, and also establish overlay tunnels. So looking more into the vRouter, Cool, okay. So you have all of your forwarding tables, your interface table, your next hop table, your MPLS table, bridge table for each of your interfaces, and then you have your tunnel overlays. It supports MPLS over GRE, MPLS over UDP, VXLAN, and working together with the physical gateway. You have your control plane that I mentioned previously, which is going to be your XMPP. And you can have, there's 4 different deployments of vRouter that I'll talk about next. But you have your vRouter agent, which is there, running in user space. That is basically going to program your vRouter and set certain policies. While the forwarder can run as kernel module, it can also run as DPDK, so you can have both your vRouter agent and your vRouter running in user space for high performance. It's more commonly used in the kernel module option that's illustrated here. So something that's different with Tungsten Fabric and vRouter is you can have different VRFs, which will have their own forwarding and flow tables, while the MPLS and VXLAN, those rules are universally accessed. The forwarding tables contain routes for both IP and MAC addresses, so you can be running different networks that won't be able to access each other unless you set those permissions. So these are the different deployments. You have the kernel module, so you have vRouter running in the Linux kernel, and your different VMs or containers on top. You also have the DPDK vRouter. This is where I've spent a lot of time on, where you have the vRouter running in user space. You also have SRIOV, which there'll be a presentation on more about later, SRIOV. And then you can also have vRouter running on a NIC, which would be a smart NIC implementation. So this is the vRouter Datapath. So when it basically works like a regular router, but in software. I'm not sure you guys, the text is kind of small, but basically what happens, it'll receive a packet, the vRouter will receive it, it'll check what kind of policy is set, what kind of packet it is, and then it'll go through the various lookup tables based on the type of traffic it's receiving. Once it figures out what kind of traffic it is, it'll check if there's a next hop, and then it'll continue going through the flow lookup table and eventually reach its destination or drop it if there's no flow action set. These are all things that you can set from the vRouter agent, which will control it and set the policies inside the vRouter. So further information about Tungsten Fabric, we have the website, the architectural overview, which a lot of this information can be found on. There's also a GitHub that has various deployments. You can use Ansible, Helm, OpenShift, Docker, and more. I also put up a link to the Open Contrail documentation. They're still migrating over to the new formatting the new name since we joined the Linux Foundation last year. I know I went through that super fast, but yeah, thank you guys for listening. Are there any questions? Yes.
So you mentioned vRouter. Does it switch also? Do you do bridging?
Yes, yes. So it does. Yes.
Okay.
Good question. So it does packet switching and routing.
Are there any commercial implementations using Tungsten Fabric or any?
Yeah, so the proprietary version of Tungsten Fabric is Juniper's Contrail.
Juniper is using?
Well, it's Juniper's software.
Okay.
Yes.
Any deployments like?
There's, if I go back, all of these companies are either using it or contributing to Tungsten Fabric. Yep. Yes?
Ma'am, does the vRouter scale horizontally on multiple VMs?
Yeah. So you can have multiple VMs or containers connected to vRouter on a single host. Yeah, it also enforces ECMP and other different kinds of setups. Yep. Any other questions? Cool. Thank you, guys.